Welcome to the Explainer. So you're getting ready for a tech interview, and you know that SQL section is coming. Well, here's the thing. It's not really about memorizing commands. It's about solving puzzles. Today, we're going to crack the code on the most common logic puzzles interviewers throw at you, so you can walk in feeling confident.
Okay, before we jump into the queries, let's start with a quick question. This really gets to the heart of why this stuff matters so much. The answer is data. Just mountains and mountains of it. And the one language that lets them command all that data is SQL. It's an absolutely essential skill, which is exactly why the top companies don't just care if you remember the syntax. They want to see how you think. They actually frame their questions as these little logic puzzles, specifically designed to test your problem-solving chops. So in this explainer, we're going to break down the 3 most common patterns you're almost guaranteed to see. All right, first up, a super common challenge: dealing with messy, duplicated data. Because let's be real, data in the wild is never perfect, and interviewers absolutely love to start here to see how you handle it. So, imagine the interviewer shows you this table. The first puzzle is, how do you even spot the duplicate records? If you look closely at employee ID 1, yep, it's in there twice. Now, the classic textbook approach is a pretty straightforward 3-step process, right? You group everything by the employee ID, then you count how many records are in each group, and then you use a halving clause to just show you the groups that have a count bigger than 1.
But here's the twist. Just finding them? That's the easy part. The follow-up question that always comes next is, okay, great, now how do you delete just one of them without getting rid of the original?
And to do that cleanly, we need to bring in the big guns, window functions. Think of them as a way to peek at a window of related rows, like all the records for one employee, without squashing them all together like a group by does.
And this solution is just so elegant. Check it out. By using the row number window function, we can assign a unique sequential number to each row within our group of duplicates. You can see it right there in that new RN column. From there, the answer is simple. You just delete any row where that number is greater than 1. Done. What's so powerful about this is that when you get a handle on window functions, you're not just solving one problem, you're solving a whole class of interview questions. You know that classic find the nth highest salary question? Suddenly it's a piece of cake. You just have to know which tool to grab: row number for simple unique ranks, or rank and dense rank for when you need to deal with ties. Okay, so that leads us right into our next common puzzle: how you combine data from different tables. Honestly, this is an area where a lot of people can get tripped up if they're not careful.
So first, they might check if you understand how to just stack data sets. The key thing to remember is the difference between union and union all. Union does all this extra work to find and remove duplicates, so it's slower. Union all is way faster, because it just grabs everything and slaps it together, duplicates and all.
But that's not the real trap. The question that's designed to be a real gotcha is about what happens when you try to join tables, but the keys you're joining on aren't unique.
Let's just walk through this so you can see it for yourself. Here's our first table. Super simple, right? It's got 2 rows, and they both have an ID of 1.
And now here's the second table. This one has 3 rows for that same ID. So, quick question before I show you the answer. How many rows do you think we're going to get when we join these 2?
The answer is 6. What happens is the database takes each of the 2 records from the first table and matches it with each of the 3 records from the second. 2 times 3 is 6. This explosion of rows is called a Cartesian product. And being able to explain that concept shows you have a much deeper understanding of how joins really work.
All right, for our final pattern, let's look at something a little more advanced, but it comes up all the time: trying to query data that has some kind of hierarchy, but it's all stuck in a single table. This is the absolute classic example. You've got one employee table, and there's a manager ID column that points right back to another employee ID in the exact same table. So how on earth do you compare them?
The trick is to just pretend they're 2 different tables. You can give the same table 2 different nicknames or aliases. So you create a virtual table for the employee, let's call it E, and a second virtual table for the manager, which we'll call M.
And that right there is the magic. The self-join lets you line up each employee's information right next to their own manager's information, all in the same row. Once you've done that, a simple where clause to compare their salaries is all it takes. It's a really slick technique for this kind of data.
So we've walked through these 3 big patterns. What's the common thread here? What's the interviewer really trying to figure out when they ask these kinds of questions?
Well, it's not just about whether you can write a query. They want to see that you can look at a problem, break it down, see the shape of the data underneath, and then pick the right logical tool to solve it efficiently. They're trying to figure out how you think.
Look, mastering these patterns will set you up for success in today's interviews. But the real skill, the one that's going to carry you through your whole career, is learning how to see the hidden logic puzzle inside every single data request you ever get. That's it for this explainer. Thanks for watching.